Welcome, I'm Oscar at TechStation, and today we're going to fix the shifter on my S13 Time Attack car. But first, we have to identify the problem, so let's go for a ride at Mantorp Park Raceway. So, how did we get here? 5 years ago, I bought this 1989 Nissan 200 SX to participate in a Swedish Time Attack championship, with a focus on participating. And somewhere along the way, this project derailed. It's currently running a fully built S13 DET engine, which in turn required us to upgrade the transmission. The Time Attack rules forced us to use a transmission from the original manufacturer of the vehicle, so the 350Z ZD009 6-speed transmission was the obvious choice. To make this work, a lot of things had to change. One of them, the shifter. Okay, let's take a look at the video again and see if we can spot the problem. While doing a quick shift from 4th to 5th, the shifter moves into the reverse gate, preventing the shifter from engaging 5th gear. Luckily, the reverse gear is opposite from 5th gear, which saved us from massive damage. We are using the GKTech shifter, and it has a pretty simple construction. The shifter moves by a ball joint mounted in a nylon housing. This brass bushing interfaces with the gearbox, and the whole assembly is allowed to move down and is held in place by a spring. This little pin and the top plate prevent the shifter from moving too far to the right. And when you press down on the shifter, the pin moves below the top plate and reverse can be engaged. The problem is that the pin is hitting the top plate at an angle. And if enough force is applied, the whole assembly will move down, opening the gate to reverse. In ordinary street use, I don't think this is a problem. But in a race situation where you shift more forcefully, this happens every time. Okay, now we know what the problem is. Now we just need to find a solution. After looking over the original design, the best option seemed to be to design a new reverse lockout mechanism. I did a couple of different designs in CAD, starting out with this pin box lock solution, and finally landing on a trigger latch mechanism. This due to size constraints and stiffness requirements. In this design, the gear shift lever can never move to the reverse position until the remotely operated latch is opened. The latch has a large surface area that the shifter can ride against and shouldn't deform even under the most frantic shift action. I used this laser cut prototype to test its function and fitment to the actual gearbox. Once I was happy with the design, I ordered the laser cut parts from my supplier. Unfortunately, the cut quality wasn't the best, but we could still make this work. Let's head out to the workshop and get some parts machined. First, we need to drill all the laser cut holes to the correct diameter. Some of the holes will later get ground pins through them, so these are first drilled undersized and then reamed for that perfect fit. Next up, I'll sandblast the parts to remove the mill scale surface and make them look a bit nicer. I should have done this before drilling the holes, but for this time I think we should be okay. Now back to the drill press to drill and ream the rest of the holes. After all that drilling, we could move on to forming the contact patch on both of the latches. My CNC machine was occupied running a long job, so we would have to do this by hand. The scribed line showed how far we needed to slant the surface to get a good contact patch with a gear lever, and then some elbow grease had to be applied. Luckily for the air die grinder, he also got some exercise, and to create that really smooth surface, I finished off with some fine grit sandpaper. Next day, we could move into the CNC machine to cut the necessary slots through the latches. After finding the center of the part, I carefully ran a 4mm 4-flute HSS end mill through the part. No gold medal in surface quality this time, but with that flimsy setup, I'm happy with the results. And then one more time on the other part. Two M4 screws will be used to hold the assembly together, and the threads are made using this handy pneumatic threading tool. After that, some quick deburring with a cordless drill. Here are the parts that we got so far, and I think it's starting to look pretty good. The mechanism will be remotely operated using a cable, so we needed to cut a couple of slots to mount the wire to the latch. This could have been done in the CNC machine, but that would have been more time consuming, especially when I could use this thin cutoff wheel to get a functional slot that would later clean up nicely with some simple filing. I didn't have any locating pins of the correct length at hand, so we had to grab some precision ground rod and cut that up to the correct length. And here's a fast way to make a nice chamfer on a small pin like this. The hydraulic press was then used to press the pin into the bottom plate. The fit was really nice, but to be extra sure I added a dab of Loctite 6300 cylinder locking glue. This would also prevent the pin from loosening from the bottom plate while assembling and disassembling this in the future. The small pin holding the return spring was then pressed into the latch. And then a quick trial fit just to see that everything works as expected before pressing in the other pins. The small pins I had were a bit too long, so I had to cut them off and file them flat. I then used the die grinder to deburr all the edges. Last feature that had to be machined was the seat for the cable, so back to the CNC machine. Now, with all the machining done, it was time for a trial fit. All the parts are going together as expected, and here you can see how the return springs function. I'm really happy with that. And here are all the parts for the shifter. The shift lever, the knob, the anti-reversal lockout mechanism, and the leather boot. Now we just need to connect the wire through some kind of metal sleeve to a knob that you can actuate while holding the gear lever. These parts will be made in the lathe. Let's head over there and load some insert tooling for aluminium. Then we add some raw stock of 6082 T6 aluminium. We will start off with a quick phasing operation and then head over to the CNC controller to program the nice radius of the knob. A quick simulation shows us that all the values look correct, and now it's time for the machine to do some cutting. Now we're back at the drill press to drill and thread a small hole for a grub screw that will be used to hold the knob in place. This spring-loaded centering pin is a handy tool to get straight threads every time. And then we'll cut it off in the lathe, so the knob is done. And now for the steel sleeve that will move the mechanical motion of the wire through the shift boot. So this is machined from a solid steel bar, and first off we have to drill out the center hole, and we do that in several steps using consecutively larger drills. That looks pretty good, so we can cut it off and head over to the drill press again. This time we're going to drill a hole for the wire, and then drill and thread a hole for a small grub screw that will hold the wire in place. And finally, we need to do some machining of this aluminium part. That was part of the GKTech shifter. And we need to make a mounting hole for the wire sleeve. And this required a very long drill, which is always interesting. And here are all the finished parts for one last trial fit. The video is getting pretty long, so this might be the perfect time to stop. And in the next video we'll do surface treatment, hardening, and then mounting this on the car. Works great. Thanks for watching, like and subscribe, and I'll see you on the next one.